the one, this is the class I usually record because this is my third time going through the notes, and I just make less mistakes on the third time. Not that I make a ton of them first period, but I have it pretty much down by now. So this will be uploaded automatically, or saved automatically to my YouTube channel, which I just use the school email. I've been trying to post them in each of the days in each of the classes, but with everything I'm doing, I'm just falling behind on that. So what I thought I would do is work smart, not hard. At the top now, if you refresh your page, don't go to it now because I'm gonna hand out notes and all this. But on the top of my schedule, I have a link for my YouTube channel. And you can just obviously click on it. And it should have, if you click on home or videos, it should have all of them that I've done. And of course, you can watch the calculus one. I'm live now, as you see. But so I don't have to post them, so I don't have to keep posting them every time. I just thought, well, just go to my channel and find the correct date. So if you're sick, if you're quarantined, if you're home alone or on remote, you can go to them and watch them anytime you want. Okay, that makes my life a little easier. Oh, I should have shared that. So Ryan, on the very, here, I'll show you, Ryan, because I forgot to share this. At the very top of my schedule, I have a link for my YouTube channel now. This is the notes, this is the notes, all right. You're welcome. All right, let's bring it up. Do I have it up? There we go. Function or not a function, to be or not to be. So there's a couple ways to present a relation, and then we're going to decide if it's a function. So this first one, no, y is raised to an even power. If you solve for that, if you solve for y, you'd have to have plus or minus. None of the x's on this one are repeated, so that's a function. And then this one fails the vertical line test, so that is not a function. I accidentally erased it, so this one should look a little different than what you have on your paper. Find f of 3a squared for f of x equals x squared minus 2x. So f of 3a squared is equal to 3a squared squared minus 2 times 3a squared. You gotta be careful here because you gotta square both of those. So this is 9a to the 4th minus 6a squared. I imagine the mistake I might see on the test is that you might leave it as 9a squared. Remember, you're squaring a square that makes it a to the 4th. This one did not go very well on the quiz. We're going to plug x plus h in for that x. We're going to plug x plus h in for that x. So we have x plus h squared minus 2 times x plus h. So that's really x squared minus 2x with x plus h plugged in. Then we're going to plug x in for x in for x. So minus x squared minus 2x. So that's this piece right here. And then it's over h. So there's the 3 pieces, the red, the green, and the blue. Well, now it's just a lot of algebra. So x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. And those first three right here, of course, that's FOIL. That's a result of FOIL. So now anything without an h needs to cancel. And it does. So we have 2xh plus h squared minus 2h over h. So 2x plus h minus 2. So we can factor an h out of the top and it cancels with the h in the bottom. That has to happen every time. All right, any questions? You got one more day to figure this one out. We got tests tomorrow. Let me know if you have any questions on that. Graph the piecewise function. So to the left of -1, we have x squared minus 2. Let's plug in -1. 1 minus 2, -1. So -1, -1. And that is an open dot. Now if I plug -2 in, we get 4 minus 2 is 2. How about we keep going to the left? -3 would be 9 minus 2 is 7. And that's probably all we're going to be able to fit there. So there's to the left of -1, excuse me. Between -1 and 1, if I plug -1 in here, I get -3. Oop, -1, -3. And 2, 4 minus 1 is 3. So -1, -3. And 2, 3. And then x greater than 2 is always -1. So that's an open dot, and it's always -1. Very similar to the one we had on the quiz, I imagine. Domain, -infinity to infinity. The range bottoms out at -3, and then we go all the way to infinity on the range. That parabola makes it go all the way to infinity. You have the domain and range. Domain is -6 to infinity. The range bottoms out at -5 and goes to infinity. Domain here is -8 to infinity because those line up. So it does cover, one stops at -3, the other starts at -3. I see that arrow there, so that's infinity. And then the range, we go from -infinity all the way up to 1. And then we also have 4 that's used as a y value. Yep. And let's clear that off. This is all calculator. Grab your calculators. I think you definitely want to play along here because tomorrow I will not be helping you with calculator. You got to know it by tomorrow. So let's go to y equals, and I'll let you get it out. We'll put that function in there. -x to the 4th. All right, to the 4th. Plus 4x squared plus x plus 1. I'm going to go to window and go from -3 to 3 by 1s and then -5 to 8. I made a correction during the day. The window was for 5 wasn't open up enough. So I went from -5 to 8 on the y. And that seemed to be a nice window to see the interesting part of the graph. Y-intercepts. To find y-intercepts, you plug 0 in for x. That rule never changes for functions, no matter what you're using. Now, that may not be obvious how to do this on the calculator, but to find y-intercept, you go second, calculate, and you're allowed this value, you can plug x's in. So number 1 is value, and you can plug a 0 in for x, and it'll tell you the y. So 0, 1. Value, it's the very first thing in calculate for y-intercepts. For x-intercepts, these are called zeros or solutions, but for the calculator, there's zeros. Calculate, number 2. I see -2 is just left, so rather than arrowing over like this, you can just punch in -2. Arrow to the right, back up a little bit. So -1.9370, that's one of the zeros. Calculate a 0. I can go to 1, arrow over. Oh, no, that's a maximum. I can still do this. I should have hit 2 instead of 1. That'll work. 2.1620. There's a rounding error on my calculator. For that y value, that's really 0. It's 0.00. It's 0.0000000000001. That's 0. Three decimal places unless told otherwise in this class. I will take off a little bit for having 2 decimal places or 1 decimal place. I'll probably take off a lot more if you have no decimal places, unless the answer has no decimal places. 3 in here, 3 for full credit. All right, maximums. Calculate maximum. Now, instead of arrowing all the way over to this maximum, I can just hit -2. It jumps it over there. Go to the right and guess. So we have a relative maximum of 3.619 at x equals -1.347. Calculate. We can do that minimum. That minimum is fairly close. Enter. To the left, to the right. Enter. That's a relative minimum of 0.937 at x equals -0.126. And then one more relative maximum. So number 4, and we're going to arrow over. That's good. Go to the right, back up. Whoops. Relative max of 6.444 at x equals 1.473. Increasing. -infinity to -1.347. So -infinity to that far left x value, that maximum that we found. We actually found that right there. Then it decreases from -1.347 to this minimum right there to -0.126. Then it increases again from -0.126. It increases from the local minimum to this maximum. And then at the very end, it decreases again. Determine if each function is odd, even, or neither. If the function is odd or even, describe the function symmetry. Show your work. This is even, has even powers. So f of x is equal to 2x squared minus 4. F of negative x is 2 times negative x squared minus 4. So that is also 2x squared minus 4. There's show your work. And the symmetry here is over the y-axis. And that's what negative x and x are saying. If you plug in a 5, that should be the same value if you plug in a negative 5. There's your symmetry. This one's odd. So f of negative x is negative x to the third minus 2 times negative x. And we have to show that that's the same as negative f of x. So negative x to the third minus 2x. That one's symmetric over the origin. This one is neither. Any questions so far? So on the last one, this one's a little different because it's not a polynomial. What we've really talked about is all polynomials. Odd power is odd, even power is even, but this isn't a polynomial. So we have to do the work. F of x is 3x minus 1 over x plus 4. Let's decide if it's even. Let's plug in f of negative x. That'd be 3 times negative x minus 1 over negative x plus 4. Minus 2. Negative 3x minus 2 over negative x plus 4. Do you think these two would give the same result? We could even try it. 3 minus 2 is 1 over 5. So if I plug in 1, I get 1/5. Plug in 1 here. Negative 3 minus 2 is negative 5 over 3. No, nope, not the same. So now we've done a little bit of the work for odd. How about the other piece? Negative f of x. Negative 3x plus 2 over x plus 4. So we got to run a negative either through the top or through the bottom. It doesn't matter. You just can't do both. So now if it's odd, then these two would be the same. They're not. They would not get the same value. This is neither. Now you might be thinking, oh, well, if it's not a polynomial, it must be either. Nope. F of x equals 1 over x squared is not a polynomial. It is even. So you got to be careful with that. Zero over 2. Think about the slope of rise over run. If I have a point and I rise 0, but I run 2, that's horizontal. The slope is 0. So think of it as rise over run. This one too, if I have a point, we rise 2, but we run 0, that makes it a vertical line. This slope is undefined. So if you don't have it memorized, just think about rise over run. Shouldn't be that bad. Write an equation in slope-intercept form given that. Slope-intercept. So slope, 4 minus 1, 3 minus negative 2. So 3/5. Now we can do y minus 1 is equal to 3/5 times x plus 2. Doesn't matter which point you pick. Pick either one. So y minus 1 is 3/5 x plus 6/5. y equals 3/5 x plus 11/5, because they're adding 1. We're adding 5/5. There we go. Write an equation in general form given the x-intercept is 3 and the y-intercept is 4. General form. X-intercept is 3. Y-intercept is 4. So here's the line. The slope is down 4, right 3. So we have y is equal to negative 4/3 x, and the y-intercept, they just tell us, is 4. So we'll just write it in slope-intercept form, the mx plus b. We have everything we need for it. But now in general form, we want x and y on the same side. So 4/3 x plus y is equal to 4. No fractions. X can't be negative. So we multiply everything by 3. Can we put the calculator down? I don't know what we're doing with it. What are you doing with it? Okay, all right, yeah. You taking notes, right? What's that? No. Some books say it does. Some books say it doesn't. It doesn't matter. Write an equation in slope-intercept form that passes through 4, negative 5 is perpendicular to that equation. No problem. X equals and y equals are perpendicular to each other. And that one has a y that is negative 5. Write an equation in slope-intercept form that passes through 2, negative 3 and is parallel to that equation. So negative 2y is equal to negative 3x minus 5. Y is 3/2 x plus 5/2. So the slope is 3/2. Parallel. All right, so y plus 3 is equal to 3/2 times x minus 2. There's point slope form. They want slope intercept form. So y plus 3 equals 3/2 x minus 3. 3/2 x minus 6. Any questions on that? Last one, average rate of change. Well, that's like miles per hour, feet per second. How far have you gone? Over how long did it take? Well, this right here in calculus, we call this the position function. So to find how far, you find out, well, where did you end up? Minus where did you start? So that's y2 minus y1. Well, how long did it take? And maybe that's 2 seconds. 3 minus 1. It's x2 minus x1. So slope and average rate of change are the same thing. So 9 minus 3 is 6. That's 10 minus 4 over 2. 6 over 2, 3. There's no labels on this one, but it would be like feet per second or miles per hour. And that average rate of change is they call it the slope of the secant line. All right, there we go. I think that's it. Test tomorrow.